Ramcharan Balaji. I study in first standard, C section, in the Presidency Public School in Sira. 5 little monkeys jumping on the bed. One fell off and bumped his head. Mama called the doctor and doctor said, "No more monkeys jumping on the bed." 4 little monkeys jumping on the bed. One fell off and bumped his head. Mama called the doctor and doctor said, "No more monkeys jumping on the bed." 3 little monkeys jumping on the bed. One fell off and bumped his head. Mama called the doctor and doctor said, "No more monkeys jumping on the bed." 2 little monkeys jumping on the bed. One fell off and bumped his head. Mama called the doctor and doctor said, "No more monkeys jumping on the bed." 1 little monkeys jumping on the bed. One fell off and bumped his head. Mama called the doctor and doctor said, "No more monkeys jumping on the bed." Is no more monkeys jumping on the bed.
Hello everyone, myself Chaya HD. I am studying in first standard D section. My school name is Presidency Public School. Today I am going to tell you the numbers rhyme. Let us learn the numbers. Let us learn the numbers. 1, 2, 3, 2, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Learning numbers makes it fun. You can learn 1, 2, 10. 1 and 2. 1 and 2. Show the numbers on your hand. Write the numbers on the sand. 1 and 2. 1 and 2. See the numbers on the wall. Tick the numbers on the ball. 1 and 2. 1 and 2. Do you want to sing along? Learning numbers make you strong. Say it. 1 and 2. 3 and 4. 3 and 4. See the numbers on the door. Write the numbers on the shore. 3 and 4. 3 and 4. See the numbers on the floor. Mark the numbers on the floor. 3 and 4. 3 and 4. Don't you want to sing along? Learning numbers make you strong. Say it. 3 and 4. 5 and 6. 5 and 6. See the numbers on the bricks. Pick the numbers on the bricks. 5 and 6. 5 and 6. See the numbers on the sticks. Pick the numbers on the sticks. 5 and 6. 5 and 6. Don't you want to sing along? Learning numbers make you strong. Say it. 5 and 6. 7 and 8. 7 and 8. See the numbers on the grid. Pick the numbers on the grid. 7 and 8. 7 and 8. See the numbers on the plate. Write the numbers on the sled. 7 and 8. 7 and 8. Sing. Don't you want to sing along? Learning numbers make you strong. Say it. 7 and 8. 9 and 10. 9 and 10. See the numbers one by one. Write the numbers on the pen. 9 and 10. 9 and 10. Shout the numbers on the run. Jump the numbers on the fun. 9 and 10. 9 and 10. Sing along. Learning numbers make you strong. Say it. 9 and 10. Let us learn the numbers. Let us learn the numbers. We have learned from 1 to 10. 1, 2, 3 to 10. Thank you everyone.
Hi, my name is Janani. I study in the first standard B section. Hi kids, come on, let's have numbers rhymes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let me number make it fun. You can read from 1 to 10. Let me number make it fun. You can read from 1 to 10. Write the numbers on the board. 1, 2. Write the numbers on the board. 1, 2. Let me number make extra. 3, 1, 2. Write the numbers on the board. 3, 4. Let me number make extra. 3, 4. Write the numbers on the board. 5, 6. Let me number make extra. 5, 6. Write the numbers on the board. 7, 8. Let me number make extra. 7, 8. Write the numbers on the board. 9, 10. Let me number make extra. 9, 10. It has a London numbers. We have 1 to 10. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Thank you.
Namaste everyone, my name is Sanidhya Pujari of grade 2. I wish you all a very happy National Mathematics Day. Do you know the great mathematician Srinivas Ramanujan was born on this day? He was the great scholar, mathematician and of course genius. As a mark of respect, his birthday is celebrated as National Mathematics Day. Today I am going to recite the backward table of 4 and 6. Shall I? 4 10s are 40. 4 9s are 36, 4 8s are 32, 4 7s are 28, 4 6s are 24, 4 5s are 20, 4 4s are 16, 4 3s are 12, 4 2s are 8, 4 1s are 4, 6 10s are 60, 6 9s are 54, 6 8s are 48, 6 7s are 42, 6 6s are 36, 6 5s are 30, 6 4s are 24, 6 3s are 18, 6 2s are 12, 6 1s are 6. I thank you everyone for giving me this opportunity to be a part of National Mathematics Day. Goodbye, have a nice day.
Myself, Anuram, staying second standard in D section in Presidency Public School. I am here to tell the reverse tables of 6 and 5. 5 10s are 50, 5 9s are 45, 5 8s are 40, 5 7s are 35, 5 6s are 30, 5 5s are 25, 5 4s are 20, 5 3s are 50, 5 2s are 10, 5 1s are 5, 6 10s are 60, 6 9s are 54, 6 8s are 48, 6 7s are 42, 6 6s are 36, 6 5s are 30, 6 4s are 24, 6 3s are 18, 6 2s are 12, 6 1s are 6. Thank you. I am studying in second standard. I am going to tell table of 3 and 6, 3 10 are 30, 3 9 are 27, 3 8 are 24, 3 7 are 21, 3 6 are 18, 3 5 are 15, 3 4 are 12, 3 3 are 9, 3 2 are 6, 3 1 are 3, 6 10 are 60, 6 9 are 54, 6 8 are 48, 6 7 are 42, 6 6 are 36, 6 5 are 30, 6 4 are 24, 6 3 are 18, 6 2 are 12, 6 1 are 6.
Namaste everyone, my name is Anay Mishra. I am studying in 30. Today I am going to say the reverse order multiplication table of 8, 9, 12 and 13.
8 tens are 80, 8 nines are 72, 8 eights are 64, 8 sevens are 56, 8 sixes are 48, 8 fives are 40, 8 fours are 32, 8 threes are 24, 8 twos are 16, 8 ones are 8, 9 tens are 90, 9 nines are 81, 9 eights are 72, 9 sevens are 63, 9 sixes are 54, 9 fives are 45, 9 fours are 36, 9 threes are 27, 9 twos are 18, 9 ones are 9. 12 tens are 120, 12 nines are 108, 12 eights are 96, 12 sevens are 84, 12 sixes are 72, 12 fives are 60, 12 fours are 48, 12 threes are 36, 12 twos are 24, 12 ones are 12. 13 tens are 130, 13 nines are 117, 13 eights are 104, 13 sevens are 91, 13 sixes are 78, 13 fives are 65, 13 fours are 52, 13 threes are 39, 13 twos are 26, 13 ones are 13. Thank you.
Good morning to all my teachers. Myself DIMR from 3rd D section. I am going to say the reverse table of 9, 12 and 13. Now I am going to start the table of 9. 9 tens are 90, 9 nines are 81, 9 eights are 72, 9 sevens are 63, 9 sixes are 54, 9 fives are 45, 9 fours are 36, 9 threes are 27, 9 twos are 18, 9 ones are 9. Now 12 ones are 12 tens are 120, 12 nines are 108, 12 eights are 96, 12 sevens are 84, 12 sixes are 72, 12 fives are 60, 12 fours are 48, 12 threes are 36, 12 twos are 24, 12 ones are 12, 13 ones are 13, 13 tens are 130, 13 nines are 107, 13 eights are 104, 13 sevens are 91, 13 sixes are 78, 13 fives are 65, 13 fours are 52, 13 threes are 39, 13 twos are 26, 13 ones are 13. Thank you.
My name is Shamit Godavi. I am studying 3rd standard B section. Now I am going to tell the tables of 8, 9, 12. 8 tens are 80, 8 nines are 72, 8 eights are 64, 8 sevens are 56, 8 sixes are 48, 8 fives are 40, 8 fours are 32, 8 threes are 24, 8 twos are 16, 8 ones are 8, 9 tens are 90, 9 nines are 81, 9 eights are 72, 9 sevens are 63, 9 sixes are 54, 9 fives are 45, 9 fours are 36, 9 threes are 27, 9 twos are 18, 9 ones are 9, 12 tens are 120, 12 nines are 108, 12 eights are 96, 12 sevens are 84, 12 sixes are 72, 12 fives are 60, 12 fours are 48, 12 threes are 36, 12 twos are 24, 12 ones are 12.
Good morning everybody. My name is Ganesh Tanvi from 4th standard A section. Today I am telling about mathematician. Today is December 22nd. This day is a great genius mathematician Srinivas Ramanujan's birthday. Ramanujan was born on December 22nd in 1887 into Tamil Brahmin Lengar family in Erode of Madras Presidency. Now it is Tamil Nadu. His father Kupputa Swami Srinivas Lengar worked as a clerk in a saree shop. His mother was a housewife. He had no formal training in mathematics. In the year 1903, when he was 16 years, Ramanujan obtained from a friend a library copy of Science of Elementary Results in Pure and Applied Mathematics by G.S. Carr collection of 5000 theorems. Ramanujan was so interested on maths that he could not focus on any other subject and failed most of them. Hardy, a British mathematician, was impressed by work of Ramanujan. Hardy arranged for him to travel 12. Cambridge of England. He was the first Indian to be elected a fellow of Trinity College and Cambridge. However, he has made a large contribution the number theories, infinite series and continued fraction. He completed over 3,500 identities and equations. Nowadays, Ramanujan formula are being used. In 1919, his health was very bad. He returned to India. When Ramanujan was in hospital, Hardy came to visit the Ramanujan. That time, Hardy told, my taxi number is 1729. It is a dull number. But Ramanujan told, it is not a dull number. It is a magic number. Ramanujan number 1729. Smallest natural number which can be expressed as sum of cube of two numbers in two different ways. 1729 can be written as 1 plus 1728 is equals to 1 cube 12 cube. Means we should multiply 1 3 times plus answer will come 1. 12 we should multiply 12 3 times, we will get 1728. Second way, 1729 expand form. 1000 plus 729, 10 cube plus 9 cube. Then we should multiply 10 3 times, we will get 1000. We should multiply 9 3 times, we will get 729. Other method, we should add all of these. 1 plus 7 plus 2 plus 9 is equals to 19. Reverse number of 19 is 91. Multiply 19 into 91 is equals to 71. Ramanujan was died in 1920 at the age of 32. During 125th Ramanujan birthday was made by National Mathematics Day by Prime Minister Manmohan Singh on 26 February 2012 at Madras University. During the 75th Ramanujan birthday, Indian government published Ramanujan's stamp in 1962. This is the life story of Ramanujan. Thank you.
Hi everyone, I am Rashid Tarpi from 4th Standard C section, the Presidency Public School Sira. Today I am going to talk a few words on Srinivasa Ramanujan. Srinivasa Ramanujan was a miraculous and strange mathematician for all time. He gave an extraordinary contribution to mathematical analysis and numbers. He was born on 22nd December 1887. His father was K. Srinivas Iyengar. He worked as a clerk in a saree shop. His family was very poor. At the age of 10, he derived the Euler's identity between trigonometrical functions. He joined the clerk post, but in his free time, he wrote the Max theorems formulas and mailed them to three well-known mathematicians. The genius mathematician Godfrey H. Hardy noticed that most of the theorems were totally unknown to Western mathematicians. Hardy invited Ramanujan to Cambridge University. Ramanujan went to London. Hardy and Ramanujan worked together. Ramanujan was player of the numbers. He showed the half dozen of new theorems to Hardy every day. He detected that the pi formula, that pi is equals to approximately equal to 3.14. He detected that the trigonometrical theorems and infinity series. His health became upset and he came in London and he came back to India. He died at the age of 33. In his short lifetime, he made a big achievement. His work was consist of 4,000 formulas in just 400 pages and 4 volumes. The government of our India celebrates the Ramanujam's birthday as the National Mathematics Day. And for the sake of the 125th birthday of Srinivasa Ramanujam, we celebrate the 2012 year as the National Mathematics Year. Srinivasa Ramanujam is proud to our country. Thank you.
Namaste everyone. This is Pavani and Yadav, class 4th A, standing before you to speak few words about Ramanujam. Srinivasa Ramanujam was born on 22 December 1887 in Erode in Tamil Nadu. He was one of the greatest Indian mathematicians of all times. He made extraordinary contribution to mathematical analysis and numbers. He also known by the man who knows infinity. He also demonstrated unusual mathematical skills by the age of 17. Ramanujam has contributed his own mathematical research of Bernoulli numbers. The government of India declared that Ramanujam's birthday should be celebrated every year as National Mathematics Day, and year 2012 he is observed as National Mathematics Year. Thank you.
Namaste everyone. I am Samriddhi Chaudhuri from 5th Standard A section. Today I am going to give a speech on two-dimensional shapes. Before that, let's know why do we celebrate National Mathematics Day. We celebrate National Mathematics Day on 22nd December every year. We celebrate it to mark the birth anniversary of legendary Indian mathematician Srinivasa Ramanujan. He was born in Tamil Nadu, India, in the year 1887. The former Prime Minister, Mr. Manmohan Singh, declared 22nd December as the National Mathematics Day in the year 2012. Now I am going to describe two-dimensional shapes. Two-dimensional shapes are shapes which has length and width but no depth. Examples are circle, triangle, square, rectangle, etc. Now I am going to tell something about circle. Circle is a closed figure. It has only one face and that is called the circular face. It has one curved side but no vertex. The enclosing boundary of a circle is called the circumference. A straight line from the center to the circumference is called a radius. A straight line passing from side to side through the center of a circle is called the diameter. The diameter is the double of radius. A chord is a line segment joining 2 points on a circle. The diameter is the longest chord of a circle. Happy Mathematics Day! Thank you!
Namaste everyone and happy National Mathematics Day. I am going to explain one of the two-dimensional figures, that is square. The figures which have length and breadth as their dimensions are called two-dimensional figures. Examples: square, triangle, rectangle, pentagon, etc. The following are the properties of square. It is also called as four-sided regular polygon. Its all four sides are equal. Its each angle is equal to 90 degrees. Its opposite sides are parallel. Its diagonals are equal, and also diagonals bisect perpendicularly. Its each diagonal divides the square into two congruent triangles. The properties of rectangle, trapezium, parallelogram and rhombus are present in square. Thank you.
Hi everyone, myself is Amulya and I am studying in 5th Standard D section, the Presidency Public School Sira, Tumkur district. Today we are going to learn about 2D shapes. The 2D shapes are the flat, plain, closed figures. We see many objects of different shapes in our daily life. Plain shapes that have only two measurements like length and breadth are called 2D shapes. Examples of 2D shapes are circle, triangle, rectangle, square, etc. If we come to the properties of 2D shapes, mainly we study face, side, vertex. Face. A face is a flat surface of plain closed figures. This is face. Side. The line segment that joins two corners of a shape are called sides. These are sides. Next comes vertex. A vertex is a point where two line segments join. These are vertex. Next, we shall learn some of the 2D shapes in detail. First is circle. Circle has no sides, no vertex. Next is triangle. Triangle has 3 sides, 3 vertices. The sides are 1, 2, 3. The vertices are 1, 2, 3. Next comes rectangle. Rectangle has 4 sides and 4 vertices. The sides are 1, 2, 3, 4. The vertices are 1, 2, 3, 4. Next comes square. Square has 4 sides, 4 vertices. The sides are 1, 2, 3, 4. The vertices are 1, 2, 3, 4. In rectangle, all the opposite sides are equal. In square, all the sides are equal. At last, I wish you all a happy mathematics day. And also I say thanks to our school management and my maths teacher to give this opportunity. Thank you, Vanessa.
My name is Likit BS. I am studying in class 6th B ICSE, the Presidency Public School. Today I am going to speak a few words about one of the 3-dimensional figure, cube, on the account of Mathematics Day. So, let me start. In our day-to-day life, you have seen many objects such as a wooden box, Rubik cube, dice and ice cube, many more. So, have you think of which shape these objects are? Yes, of course. These objects are in the shape of a cube. So, what is this cube? We'll learn now. A cube is a solid 3-dimensional figure which has 6 square faces, 8 vertices and 12 edges. Okay, now we'll see how this cube has 6 faces, 8 vertices and 12 edges. With a model. See, I have a model. Now I'll count. Okay? It has 6 faces, I told. 1, 2, 3, 4, 5, 6. It has 6 faces and 8 vertices. 1, 2, 3, 4, 5, 6, 7, 8. And 8 vertices and 12 edges. 1,
2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, it has 12 edges. We have seen a cube has 12 edges, 8 vertices and 4 square faces. Now we will discuss about the properties of a cube. First property says that all the faces of the cube are square in shape. See, all the faces of the cube are square in shape. And second property is all the sides of the cube have equal dimensions. See, they have equal dimensions. And all the angles of the cube are right angled. Right angle means 90 degrees. See, they are right angled. Then the last, the sides are opposite to each other, since they are parallel to each other. We can say that they are parallel to each other. See, parallel to each other. These are the properties of a cube. Then we will see the examples of the cube. Examples are Rubik's cube, ice cube, then many more. Dices also will come for examples. So this is all about the cube. Once again, I wish you a happy Mathematics Day. Thank you.
Namaste everyone. My name is SS Anushka from class 6th. So today my topic is properties of a cube. So we all know that a cube is a three-dimensional shape. But what is a three-dimensional shape? It can be defined as a solid figure or an shape with 3 dimensions. The length, the width and the height. So this is called the three-dimensional shape. So next is in a cube there are always 6 faces. So this is one face. The first is front face and the back, the top, the bottom and the sides. So there are totally 6 faces in a cube. And there are 12 edges in a cube. That is this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So there are 12 edges in a cube. And then to calculate the area of a cube, we should remember the formula 6a square. So this is the formula to calculate the area of a cube. So let's take an example. 5 centimeters. So we should write 6 into 5 square. And next is 6 into 5 into 5 equals to 150 square centimeter. So the answer is 150 square centimeter. So the area of this cube is 150 square centimeter. So this is how we find the area of a cube. Then let's discuss some examples of a cube. Some examples are Rubik's cube and dice. So these are some of the examples of a cube. So now we have learned what are three-dimensional shapes, and the cube has 6 faces and 12 edges. And also we learned how to calculate the area of a cube. And also we've learned some examples. Thank you.
Don't fear for facing failure in the first attempt, because even the successful mathematics starts with 0 only. Hello everyone, this is Sonali Gonchikar of class 6D. Today is a special day for all of us. Yes, I wish everyone a very happy National Mathematics Day. Today I am here to give a short note on one of the solid figure, cone. A cone is a three-dimensional geometric figure that has a flat surface, a curved surface pointed to top. A pointed end of a cone is called the apex, the flat surface is called the base. The three main properties of cones are: it has one circular face, it has 0 edges, it has one vertex. A cone can be of two characters depending upon the position of the vertex on the base. A right circular cone is one whose apex is perpendicular to the base, which means that the perpendicular line falls exactly on the center of the circular base of a cone. If the position of the vertex is anywhere apart from the center of the base, then it is an oblique cone. Some of the examples that which we can see around us are: a fire is shaped like a cone, an ice cream is shaped like a conical shape, the barrels which we can see on the roads are also conical, the birthday hats which we wear are also conical in shape. Thank you one and all.
Namaste to everyone. Today I am going to explain you about the RHS rule of congruency. Now first, what is the meaning of congruency? What will we understand about this congruency matter? Congruency means if two triangles, all the three sides are of same length and their size is the same. This is called congruency for triangles. Today I am going to explain you about the RHS rule of congruency. What is this RHS? RHS full form: right angle, H stands for hypotenuse, S stands for other side. How can we say that? How can we prove that RHS can be used for two triangles congruency? Now, RHS. Now, if hypotenuse, this is hypotenuse, the side opposite to the 90-degree angle is called an hypotenuse. Hypotenuse C is equal to hypotenuse R. And side A is equal to side B. And angle B, that is right angle B 90 degree is equal to angle Q 90 degree. So this is how we can make this into use to prove that they are congruent. You can ask me a question. What about this side? This side will automatically fix. How can it fix? I will come to that point. Please know RHS or SSA. You can call it as SSA because this is R, hypotenuse, or you can call it as a side. This is P, you can call it as S, side. And this is 90 degree. It is an angle. A. Yes, A. Yes, you can call it as SSA. This rule, RHS or SSA rule, is only applicable for right angle triangle.
Namaste everybody, I am Master Joshi of 7C. Congruency of triangles simply means the equality of triangles. There are different postulates to prove the congruency of triangles. They are RHS, SSS, SAS, ASA and AAS. Now I would like to explain RHS. In RHS, S stands for side, R stands for right angle. This applies only for the right angle triangle. The opposite side of right angle triangle is hypotenuse. This condition says that the two right triangles are congruent if the hypotenuse and the side of the triangle are respectively equal to the hypotenuse and the side of another triangle. Suppose if we have a right angle triangle at the angle ABC is 90 degree and the hypotenuse is
5 unit, that of a length is 3 unit. Similarly, if you have a right angle triangle at the angle PQR, at the vertex of Q is 90 degree at the same length of hypotenuse, the side is 3 unit, the two right angle triangles are congruent. We don't even need to know the other sides of the triangle. Thank you.
Namaste everyone. Myself Jivika and I'm of class 8C. I wish a very happy Mathematics Day to all. Every year, 22nd December, we celebrate as the birth anniversary of Dr. Srinivasa Ramanujan and as the National Mathematics Day. The National Mathematics Day was declared by the Government of India by the Prime Minister of India, Manmohan Singh, when they were celebrating the 125th birth anniversary of Srinivasa Ramanujan. This year, we are celebrating the 133rd birth anniversary of Dr. Srinivasa Ramanujan. This year, we are celebrating Mathematics Day virtually. My topic is the sum of interior angles of a triangle is equal to 180 degree. I will prove that the sum of angles of triangle is 180 degree. Let's get started. Now let's prove that the sum of interior angles of a triangle is equal to 180 degree. First, take a triangle. It may be of any shape. It may be of isosceles or equilateral, etc. After taking the triangle, mark the angles of the triangle. A,
My name is Vismay TR. I am here to prove that the sum of interior angles of a quadrilateral is 360 degree. We have to prove that angle A plus angle B plus angle C plus angle D is equal to 360 degree. Draw a diagonal from angle A to angle C which separates the angle A into two angles, angle 1 and angle 2 and separates angle C into angle 3 and angle 4. Hence, we can tell that angle A is equal to angle 1 plus angle 2 and angle C is equal to angle 3 and angle 4. Since the quadrilateral is divided into two triangles, therefore the sum of angles of a triangle is equal to 180 degree. In angle ABC, angle 1 plus angle 3 plus angle B is equal to 180 degree. And in triangle ADC, angle 2 plus angle 4 plus angle D is equal to 180 degree. On adding angle 1 plus angle 2 plus angle D plus angle B plus angle 3 and angle 4 is equal to 360 degree. Therefore, angle 1 and 2 is equal to angle A. So it can also be written as angle A plus angle B plus angle D plus angle 3 plus 4, which can also be written as angle C, is equal to 360 degree. That is, angle A plus angle B plus angle C plus angle D is equal to 360 degree. Hence, it is proved that sum of interior angles of a quadrilateral is 360 degree. Thank you.
Namaste everyone. My name is Anusha Chal of class 8C. I wish everyone happy Mathematics Day. I am here to give a presentation on theorem. Before that, let us learn what is theorem. Theorem is a statement that can be demonstrated to be true by accepted mathematical operations and arguments. I am going to explain and prove the theorem. The theorem is exterior angle of a triangle is equal to sum of the interior opposite angles of the triangle. For example, let's take this right angle triangle. In this triangle, angle A is equal to 30 degree, angle B is equal to 90 degree, angle C is equal to 60 degree, and the exterior angle is equal to 120 degree. Here, let us prove the theorem. Exterior angle of a triangle is equal to sum of interior opposite angles of the triangle. Angle 1 is equal to angle A plus angle B. Angle 1 is equal to 120 degree. Angle A is equal to 30 degree. Angle B is equal to 90 degree. So, 120 degree is equal to 30 degree plus 90 degree. 120 degree is equal to 120 degree. Hence, we proved. Thank you.
Namaste everyone. Myself Bhumika Beer of class 9 standard C section. First of all, I wish everybody happy Mathematics Day. Maths is a different perception to different people. For some it's very dangerous, and for some it's very boring, and for some it's very interesting. And for those to whom maths is interesting, I wish once again happy Mathematics Day. Once Shakuntala Devi was asked a question, what is mathematics? She said mathematics is a systematic effort to solve the puzzles given by the nature. But according to me, mathematics is very important. Life without mathematics is just like a body without soul. Mathematics Day is celebrated in India in every December 22nd to commemorate the birth anniversary of Srinivasa Ramanujan. This declaration was made by former Prime Minister of India, Manmohan Singh, and to commemorate the birth anniversary of Srinivasa Ramanujan. He declared when he was visiting Madras University to pay tribute to Srinivasa Ramanujan's achievements. This declaration was made on February 26, 2012. Without wasting time, let's start solving Sudoku. First, let me explain the basic rules. Each box is known as cell, and this vertical column is known as column, and this horizontal box is called as row. Each box is called as grid. So there are 9 grids, 9 rows, 9 columns, and 81 cells. First, to make our Sudoku very easier, let's give names for each rows and columns. As A, B, C, D, E, F, G, H, I. 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's start solving the Sudoku. You may ask how to solve the Sudoku. Basically, see, there are 9 grids and 9 columns and 9 rows. So you have to fill in each row and column numbers from 1 to 9 without the repetition of numbers. That is the major rule. So let's start solving it. First, to solve, see, are there numbers occurring twice? See, in this row, in this column, 7 is occurring already. In this row also 7 is there, but in this row 7 is not there. We can write here also, but we should not write, because in this grid already 7 is there. In this grid also 7 is there. So definitely 7 will come here. Here let us see any numbers occurring twice. See, 8 is there, here also 8 is there. It's finished. Now 9 is occurring in this column also, in this column also, but in this column 9 is not there. So we cannot write here or here because 9 is already in this grid. Here also we cannot write because 9 is already here. So we have to write in these 3 boxes only. I shall write it here. Next, let's check row wise. Here also no, here 8 is there, here also 8 is there. So 8 must come in these 3 boxes. I shall write it here. Here also, are there any numbers occurring twice? Yeah, here 3 is there, here also 3 is there. So definitely 3 must come here. Are there any other numbers? 8 is there in this row also, in this row also.
But in this row 8 is not there. 8 is already present in this column, so I shall write it here. Yeah, let's go to next. 9 is there in this row also, in this row also, but in this row 9 is not there. I shall write it here. Then 5. 5 is here, there in this row also, in this row also, but here 5 is not there. I shall write it here. This Sudoku almost goes with a guess. And 6 is not repeated, 5 is repeated, 6, 9, everything is okay. Now to solve Sudoku we have to start filling the numbers. Okay, in this grid we have to fill 1 to 9. So there are already 4 numbers, still 5 numbers are missing. So in this row 2 and 8 are already there, so we should not repeat 2 and 8. So 2 must come here. In this 2 and 8 must not be repeated, 2 and 8 are already present. In this 9 must not be repeated, so I shall write 9 here. Then 4. 4 must not be repeated here, so I shall write it here. Then which are the numbers missing? 3 is missing and 5 is missing. 3 is already in this row, I shall write it here. Then which is the only number missing? 5. I shall write it here. See, one grid solved. Next, we shall go to next grid. In this 5 numbers are already there, only 4 numbers are missing. In this way shall we fill 1. 1 is already here. This row is also filled. So in this row only it has to come. I shall write it here. Then 2. 2 we have written here. Here no space. So definitely see 2 must come here only. 3 is there, 4 is there, 5 is there, 6 is missing. 6 is already in this row. So I shall write it here. Which is the only number missing? 9. Yeah. Next, 1 is there in this column also, in this column also, but in this column, see, 1 is not there. I shall write it here. Then 2. 2 is there in this column also, in this column also. In this column, that in this grid we have to write. Then 3. 3 is there here also, so I shall write it here. Because see, 3 must not be repeated in this row also. So. Then 4. 4 is there here also, See, 4 is there in this column also, so definitely it has to come here. Next, 5. 5 is already there. 6, it must not be repeated here, so we shall write it here. Next, which is the only number missing? 8. Let's come to this grid. 1 is already here, I shall write it here. 2 is there. Then which is next? 3. 3 is already here, so we shall write it here or here. 4. 4 is already in this grid, I shall write it here. Next 5. 5 is already in this row, I shall write it here. Then 6. 6 must not be repeated here also, so here also, so I shall write it here. Then 7. 7 is already repeated in this row, so definitely 7 will come here. Next number is missing, 9. Next we shall go to next grid. 1 is already there in this row, in this column also, but 1 is missing in this column. We should not write 1 here in this 3 boxes because 1 is already repeated in this row. 1. Next 2. 2 is repeated here also, so definitely 2 will come here. Next 3 is already there. 4 should not be written here. We shall write 4. Here also it's repeated, so we shall write 4 here. Then 5. 5 is already repeated here, so we shall write 5 here. Here also 5 is repeated, so we have to write 5 here. Then 6. 6 is already repeated here also, so definitely 6 will come here only. Next 7. 7 is already here and 7 is already here also, so definitely 7 will come here only. Next, which is the missing number? 9. See, almost fit. Now 1 is there, 2 is already here also, so 2 must come here only. Then 3 is already repeated here, I shall write it here. Next 4 is already here also, in this column 4 is not there, I shall write it here. Next, which is the number missing? 7. See, 6 grids are filled. Here 1. See, 1 is there in this row also, but here 1 is not there. Next 2 is there here also, here also 2 is there. See, only here space is there, we can write 2 here. Next 3 is repeated in this row also, we shall write 3 here only, because see, we shall write here, but 3 is already repeated in this column, so I shall write 3 here. Next 4 is there in this also, in this column also, so we shall write 4 here, because see, 4 is already repeated in this column also. Next 5 is there here also, here I shall write 5. Next 7 is there here also, so definitely 7 will come here. Then which is the remaining number? 6. Next 1. Yeah, 1 is there here also, and 1 is there here, so we shall write it here. 2 is there, 3 is there. Next 4 is there here also, it must come here. Then 5 is there here also, so it shall come here. Then 6 is repeated here also, so we shall write here. Number missing 7. We have almost completed. 1 is there here also, so 1 must not be repeated here also. So this is the only box. 1. Next 2 is repeated here also, then here also, so 2 must be written here, because 2 is already filled in this row also. 3 is there, 4 is there, 5 is there. 6 is repeated here also, and here also, so 6 must be written here. Then 7. See, 7 is repeated in this row also, here 7 is not there, so we shall write it there. Then which is the only number missing? 8. Hence, we solve the Sudoku. Sudoku is an easy game but a tricky game. Thank you.
Namaste to all my respected teachers and my dear friends. Today I am going to show you how to solve Sudoku. This is the solved Sudoku which I am showing on the screen. Sudoku has taken the world by storm, but there are still millions of people who do not know how to play the game. Are you one of those people, or are you already an avid Sudoku player? If you play Sudoku regularly, you probably know about the rules. However, there are many people who do not consider Sudoku a viable pastime because they believe that it is a mathematics-based game. While Sudoku is based on a concept invented by a Swiss mathematician, it requires no arithmetic knowledge and is purely a logic-based game. Anyone can play Sudoku, including you. Are you ready to learn the rules? Sudoku rules for beginners. Only use the numbers 1 to 9. Avoid trying to guess the solution to the puzzle. Only use each number once in each row, column and grid. Use the process of elimination as a tactic. Use cross-hatching and penciling in techniques. By following these simple rules, you should be able to work out the solution to just about any Sudoku puzzle that you encounter. If you find that a puzzle is proving impossible to solve, it is probably the difficulty level of the puzzle that is the problem, and not because you are not following the rules correctly. If you have not played Sudoku before, these rules probably do not mean much to you. They would make more sense with a bit more understanding of the objective of the game and more insight into each rule. This article aims to provide beginner players with some valuable insight into the game rules without getting too complicated. Let's see the preface. To solve expert Sudoku puzzles requires notes and strategies. We use strategies to reduce the number of candidates in unfilled cells. Here are 9 strategies that are used most often in my experience or solving expert Sudoku puzzles. Amazingly, these 9 strategies have also been sufficient to solve virtually all the puzzles we encounter typically online. Top 9 most often used strategies ranked by frequency of use: naked singles, hidden singles, naked pairs, pointing pairs or triples, climbing pairs or triples, naked triples, X-wings, hidden pairs, naked quads. First, naked single. A cell with only one candidate is called a naked single. The sole candidate is the solution to the cell. All other appearances of the same candidate, if any, are eliminated if they can be seen by the single. There are 3 naked singles in this example. Second, hidden single. A cell with multiple candidates is called a hidden single if one of the candidates is the only candidate in a row, a column, or a block. The single candidate is the solution to the cell. All other appearances of the same candidate, if any, are eliminated if they can be seen by the single. Third, naked pair. 2 cells in a row, a column, or a block having only the same pair of candidates are called a naked pair. All other appearances of the 2 candidates in the same row, column, or block can be eliminated. Pointing pair or triple. When a certain candidate appears only in 2 or 3 cells in a block and the cells are aligned in a column or a row, they are called a pointing pair or triple. All other appearances of the candidate outside the block in the same column or row can be eliminated. Claiming pair or triple. When a certain candidate appears in only 2 or 3 cells in a row or a column and the cells are also in a block, they are called the claiming pair or triple. All other appearances of the candidate in the same block, if any, can be eliminated. 6. Naked triple. 3 cells in a row, a column, or a block having only the same 3 candidates or their subset are called a naked triple. All other appearances of the same candidate can be eliminated if they are in the same row, column, or block. 7. X-wing. When a candidate appears in 4 cells that form the corners of a rectangle or a square, and it appears only in the 2 cells in both rows. All other appearances of the candidate in the 2 columns, if any, can be eliminated. It also works if rows and columns are switched around. 8. Hidden pair. When a pair of candidate appears in only 2 cells in a row, a column, or a block, but they aren't the only candidates in the cells, they are called a hidden pair. All candidates other than the pair in the cells can be eliminated, yielding a naked pair. 9. Naked quad. 4 cells in a row, a column, or a block having only the same 4 candidates or their subset are called a naked quad. All other appearances of the same candidates can be eliminated if they are in the same row, column, or block. Epilogue. Armed with these strategies, solving a Sudoku is still not without challenges. The challenges are in pattern recognition. It takes a lot of patience and practice to spot the patterns among the multitude of candidates where the strategies can be applied to. Like everything else in life, the old adage that practice makes perfect also applies to solving Sudoku puzzles. Thanks a lot.